Polyols are compounds containing multiple hydroxyl OH groups, serving as key building blocks for polyurethanes, coatings, adhesives, sealants, and elastomers, case applications. Bio-based polyols are derived from renewable resources such as plant oils, sugars, lignocellulosic biomass, or waste materials instead of petroleum feedstocks. Their production aims to reduce carbon footprint, dependency on fossil resources, and improve sustainability in polymer manufacturing. Bio-based polyols are favored for their reduced reliance on lower carbon footprints and fossil fuels. Additionally, performance requirements, such as resistance to wear, chemical resistance, and UV stability, contribute to the need for advanced polyols. Sources of bio-based polyols. Bio-based polyols can originate from several renewable sources. Vegetable oils such as soybean oil, castor oil, rapeseed oil, palm oil, linseed oil, and jatropha oil. Fatty acids or triglycerides are chemically modified via epoxidation, hydroxylation, or transesterification to introduce hydroxyl groups. Example: epoxidized soybean oil, ESO, converted into soy-based polyols. Carbohydrate-derived polyols. Carbohydrates such as glucose, sorbitol, sucrose, glycerol, and mannitol are used directly, for example, sorbitol polyols, or converted via fermentation to polyether or polyester polyols. Lignocellulosic biomass. Derived from cellulose, hemicellulose, or lignin. Lignin-based polyols and cellulose-derived polyols use depolymerization followed by hydroxyl functionalization. Waste and byproducts. Crude glycerol from biodiesel production and carbon dioxide, CO2-based polyols via catalytic carboxylation are emerging feedstocks. Production and chemistry. Common chemical routes include epoxidation of unsaturated oils in a ring-opening reaction with alcohols or acids to get polyols. Hydroformylation, adding formal and hydroxyl groups to unsaturated bonds. Oxypropylation of sugars, reaction with propylene oxide. Polycondensation of bio-based diacids, succinic, adipic, and polyols. Resulting polyols can be polyether type, for example, glycerol-based, sugar-based. Polyester type, from bio-based diacids. Hybrid type, partial bio-content blended with petrochemical components. Bio-based polyols are used across various industries: polyurethane foams, coatings and adhesives, elastomers, automotive, and construction. Bio-based polyols bridge renewable chemistry and high-performance materials. They enable polyurethane and coating industries to transition from fossil dependence toward carbon-neutral, circular manufacturing with enormous potential in construction, mobility, and consumer goods sectors. According to the market research done by Grand View Research, the global polyols market size was estimated at $41.6 billion in 2024 and is projected to reach $67.5 billion by 2030. The market growth is attributed to polyols' beneficial properties, such as strength, resilience, and energy absorption, which make them ideal for commercial and consumer products, including bedding, furniture, transportation, textiles, carpet cushioning, packaging, and fibers. The bio-based polyols market is growing rapidly due to sustainability mandates and green chemistry initiatives. The global bio-based polyols market share is dominated by polyether polyols, which hold a significant majority, around 65%, due to their extensive use in flexible foams for furniture and automotive applications. Other types, like polyester polyols, are growing for their use in rigid foams, coatings, and adhesives, while the overall bio-based polyols market is projected for substantial growth from approximately $5.33 billion in 2024 to over $12 billion by 2034. Due to increasing environmental concerns and fluctuating raw material prices, major companies are turning to bio-based polyols to reduce their reliance on petrochemical-derived options. Many companies are actively exploring the development and marketing of bio-based polyols, recognizing their potential future benefits, especially as regulatory authorities push for environmentally friendly products. The growing demand for bio-based polyols is driven by a shift towards more sustainable and environmentally friendly materials in various industries, including automotive and construction. These polyols, derived from renewable resources, reduce reliance on fossil fuels and lower the carbon footprint of polyurethane products. As consumers and manufacturers become more environmentally conscious, the market for bio-based alternatives continues to expand, fostering innovation and encouraging the development of greener formulations.